Hi and good morning, everybody. My name is Axel, and welcome to my presentation from zero to hero. And I will show you our implementation, how we use Icinga and configure it. As an introduction, I work for the Institute for Medical Education, and this is at the University at Bern. The university has about 6,000 employees. And our faculty is located, our institute is located below the Faculty of Medicine, and we are about 80 employees. We provide support for exams with preparation, translation, performing the exams, and analyzing them for all medical faculties in Switzerland. And that is for electronic exams and exams on paper. Additionally, we have a lot of e-learning tools for medical students at the university. We make video productions and many things more. From the view of the network, I'm located on the left side at the University of Bern. That's our network where we have several subnets networks. We have about 30 physical machines, and we have a virtualization infrastructure to run virtual machines based on KVM. And here at this location is our Icinga master. A few years ago, we moved a lot of virtual machines outside to a provider which works for all Swiss universities named Switch. And from the view of Icinga, it is quite basic. At the provider, we have an Icinga satellite which can send its data to our master. So how did we start with Icinga 2? I came to the institute about 10 years ago, more than 10 years ago, and there was a great tool named Snagios 3. And I really hated to configure anything in it. And luckily, if we started to build up a new environment with Puppet, Master, and Foreman, we switched to another monitoring tool called Sensu, which was really quite nice to automate. It was very simple, and new checks and new hosts appeared within a second in the display. And it used also Nagios-compatible check scripts. That is a small screenshot from Uchiwa, the tool we used to display the monitoring information. And I really liked it, but in the end of 2019, suddenly Sensu was end of life, and what was even worse, they removed all repositories. So if we set up a new machine, we couldn't put a new monitoring client on it. So we were a bit under pressure to find a new monitoring system, and the requirements have been, it must be free software, because all our systems are Linux-based with free software, Apache, MariaDB, Postgre, and other open source tools. We wanted to have APIs to automate the rollout or everything what comes into our mind. We wanted to give access to non-sysadmins which have a limited view, which was not possible in Sensu. That the product owners and developers can see their own machine and see what they are doing without asking us. We wanted to have performance graphs back, which we had in Nagios, but not in Sensu. And we wanted to have notifications. So we had a look to several tools, like yesterday the speaker said. They also had a look to Zabbix, OpenNMS, and finally we decided for Icinga. And beginning of 2020 was the start of Icinga 2 in our environment. Yeah, we have an intranet, we build it up, and there is a kind of a user portal. And there the users can set a password, they can upload their SSH key and see their applications where they have access to. And those information from the intranet were stored in the database of the intranet server. And because the first use case for our Puppet Master was to put the SSH key of a user to the right target system. So we built up a link for the Puppet Master to access the database, to roll it out. And if we had the link to the database, we started to put some more information into the database, like our monitoring checks. If we switched from Sensu to Icinga, it was just a switch to the same data source. We just wrote another Puppet class, which makes other things on the client. For a few years, we switched to Ansible in the meanwhile, and we kept the approach to read the database from there. So how does it look like? How do we configure the checks? In the first screenshot here, it is an open LDAP instance. We see very common information. I have here a check with a name, with a description, a command, an icon, interval. All these information you know if you work with Icinga checks. And because one command with its parameters doesn't fit all machines in the same time, we have customizations. One of the customizations is setting another command line for a specific host. And our convention is to set command underscore fqdn and give its parameters. Additionally, we have some more values next to the check information. Here we see a check for the smart check of a hard disk or SSD, which requires that this check can be only installed on a machine which is a physical one. So we have a keyword named must-be, which decides, it is a flag for us. It decides, is it a check for a physical machine or is it for a virtual machine? The next variable there, packages, we can add package names to install that the check can run on the target system. So we installed SmartOne tools here for that one, but it is a list like you can see, so we can add several packages there. Sometimes also the case is that because the Icinga client runs as an unprivileged user, it needs sudo permission on given tools. We also put this information with a sudo cmd line into the check itself. So we have seen our checks are in the database. That's nice, but we want to have them somewhere else. Now comes the director into play. It has a section automation. This is used to fetch information from other data sources like SQL databases, or LDAP is accessible too, maybe other sources, I don't know it such well. And you can make pull actions, read data, you can cut, splice, reorganize the data, and then finally import them into director objects. We use this import for commands only, we have seen before. But you also could import other objects like hosts. After watching a single check, we must somehow organize it to, once again, we had a look to single checks so far, and how do we apply checks? I show you now. In Ansible, we use groups. We have one groups for default, which will be applied to each system we install, independent from its service it provides. And here are things like CPU usage, server load, net I/O, and such things. And additionally, with SVC prefix, we have all the checks which are delivered for a special service or application. These groups, here is a snippet from an Ansible playbook which installs the client for us, and it has two variables, and in one variable we have a list of all the services which must be installed. The EML default group is not here because it is installed by default and it is inside the role. A second variable below is a list of ports to check. It will force the TCP check for this host. Just a word for Puppet, because I said a few things for Ansible. Before Ansible, we used the Puppet Master. There it was much easier to handle all the checks because during runtime you were able to see the list of all classes or modules which will be executed. And so we put all the checks directly on the Puppet class names. This is a much simpler approach for automation. How does our rollout work? If we start the Ansible playbook we have seen before and come to that point that will install the Icinga client, we already have installed the Icinga software, and we need to add we have to make the step backwards what we have seen before. We have to read the database by the list of groups. For each in each group are the checks linked. We have to read each check, and for each check we handle its extra variables. We install the packages, we apply the sudo commands if needed, and so on. Additionally, we have to prepare Icinga that a new host arrived and has its services and wants to send data to Icinga. And that's why we will create, on one hand, the host object in the director, and we will create the service object in the director. And the service object is linked to the service template, which is linked to the check command, which we already imported before with the director. But during an install process, we verify if a service already finds the service template. So we have to check 3 objects. And to do so, it is not implemented in Ansible. I wrote it in Bash and used curl for HTTP processes, and for creation of JSON strings, I use the binary yo. Before accessing the director, you need to create a user for sure and a password, and you have to create a role, and this role has a permission on the Icinga director module. So the endpoint for the Icinga director is below Icinga Web on port 443, and behind Icinga Web is a folder named director, followed by the object name you want to access, and then followed by its parameters and optionally JSON if you send put or post. If the Ansible playbook runs, we cannot just create an object, we must verify if the object already exists, because on the second run, if an object exists, it will fail, because you cannot create an existing object again. So we have to make 2 steps. First, read with a GET request if the object exists, verify the status code. If it is a 404, the object is not yet existing, we start a put command to create it with a JSON string, or we send a post request to maybe update the current check or host. But at this point, I would like to stop because it's too many details to show the JSON for each object type. I would recommend to the Icinga documentation online, or maybe you ask me if you want to see it in live. Just as an additional info, we also verify if we change the checks. If a check is deleted for a service, we will send a delete request that it will be removed from the director. So, our own checks. If I look backwards, how it developed, if we set up the new Icinga installation, there were maybe 3 phases. The first one was implementing the basic checks. We added unspecific checks which can be applied on each system, or mostly. We have used the default packages in the Linux repository, like monitoring plugins or Nagios plugins. They have different names depending on the operating system. And we integrated Graphite already in the first phase to have performance graphs. The second phase We created specific checks for all our services we have running in our environment, starting with that one with the biggest pain points, and then continued service by service. The implementation speed is lower because it needs time to create a check or find the right check, and then you apply it only to a few machines and not to all, so the increasing speed for number of checks is lower here. And in phase 3, if you are nearly feature complete, I call it the fine-tuning phase. There we create other checks to integrate other processes, or if we introduce new services, that we write new checks and add them. So here are times where no new checks will be added, then it's a small jump, and then a flat curve again. The checks, what we currently use, I said that we use the standard Nagios checks. We have 2 SNMP checks for printers and for our Xenology base. The SNMP check is wrapped by an own script that handles the SNMP v3 or version 2 authentication. I also started to write checks myself using Bash. The main reason was that I want to see much more information. If I open Icinga and see a problem, the one-line output for me is very often not enough or hard to read. And if I compare the count of Icinga checks or service checks in general before we used Icinga, I haven't right in my mind, but it was maybe between 10 and 20 checks per host. And in the meanwhile, if we have 30 checks by default, additionally the checks which is service specific, we have systems with 50 up to 70 checks. And for sure we have performance checks too, which also increases the number of checks we use. Let's have a look to the third phase, the fine-tuning phase. How do we integrate other processes? We did this because I want to have a single system I want to look at in the morning and have an overview for the total status of our network. I don't want to look into 3 different tools to read different status and merge it by myself. And that's why we added other processes or things we wanted to see into Icinga. It is very basic, but it's very effective. The approach is to use a custom script which returns 0 if it is okay, or non-zero if there's an error, and it will be triggered in the interface. And if I see it in Icinga, then I can log in to the other tool to find out some more information. The other approach next to the check script is if you have an URL which provides an JSON output, we can fetch it, and with a JQ command, it will be filtered and then shows the result. For this, I want to show you some snippets and checks online, live here. First, a snippet of Bash code. It is really simple as it looks like. You take a variable which has the output after execution of a command, and then in the next line you get the return code, and then you can maybe react only on the return code, or if you want to have more details, you can grab inside the output and display it. So the first check I want to show is integration of cron jobs. I know that the most people here use Linux. How many people use Linux checks? Maybe 99.8%. And how many of you monitor cron jobs? 1, 2, 3, 4, 5. A few. If you see such a cron job, Linux cron jobs by default, the problem is if you redirect the output of a command, you must read it somehow. You must find out if this execution is a correct one or not. And if you could do this, if you are able to go to each server and find it out, If you have a log file which looks okay, which is 3 hours old, but if the cron job runs every hour, you need to know, it didn't run the last hour. And to determine that, I have a wrapper for that, which I want to show you now. Script Summit. Okay. Okay, I'm here in the installation directory of the cron wrapper, and inside it is a script cronwrapper.sh, and in front of the script or command I want to execute, I just placed a wrapper script additional with a parameter for the TTL, the time to live, how often this cron job must run. And as an example here, is it too low? Is it readable? Maybe this is better. As an example, I have here a 1-minute TTL, and I execute an ls command to list the files. And what happens is I see nothing. This is the behavior I want, because a cron job doesn't have to write something out on standard out or standard error. But it writes a log file, which is listed in the next command. And the last file we have here, it is a log file name which is created by the fqdn of the current host, which is my laptop here. And ls is a label created from the given command, but you also can add a custom label too. If I have a look to the output of it, we see that it is not just the output of the command I executed. I have meta information with a variable equal sign and then the value, and there I can access different meta information, the executed script, starting time, execution time, return code, and so on. And the output of the script as well. And the result of it is very easily to grab to find out if all cron jobs are running well or not, but you do not need to execute the grep command yourself. There is a check script for that. And with a parameter -s, it shows the list of all executed cron jobs on the system. We see our ls command is okay. A second one, my local backup didn't run because it was off yesterday. Okay. And next to the short list, we also can have a look to the output with more meta information. And we see here the information what we have seen in the log file. And additionally, we get a list of the last executions. How long did they run and what the return code was. And yes, we see our ls command is okay because the return code was 0 and it is not expired yet. And my cron job, which has to run yesterday, there is an error on it. Then we have a look later. Okay, but this script will also return a non-zero exit code if it fails. And a non-zero exit code we will display in the Icinga monitoring as an error. And finally, it looks like that. I have a cron job entry with the number of cron jobs which have to run there and how many errors occurred. And if you show the details, you see the short status and afterwards the longer status. The next check I want to show is a check of end of life. We verify when operating systems or used products like databases, MySQL, Postgre, or programming languages will be out of time, end of life, and not supported anymore. And this is the second demo. Okay, to do so, I have a check script named check_eol, and it has parameters with a keyword for a product or for the operating system. And in the first execution, I give it a version number. Debian 11 is an operating system which is up to date. And if I make the probe with an outdated version, it will give us the information that it is already gone and not supported anymore. And how is it done? It is more simple than you expect. I have a text file with product keys. My delimiter is a double colon, followed by a version number, followed by an end-of-life date, and optional a comment. And next to operating systems, I have some more config files for programming languages, for databases, which have the same syntax. You do not want to add the version number of any product into your checks, and that's why there's a detection mode to find out the version or to find out the operating system and version. And here I started it with Node. On my laptop I have Node version 22, which is still alive because it was just installed a month ago. And how the version detect works, in a subdirectory I have several detection scripts which are based on the version command of a tool. Here the Node.js will be executed with --version, and from the output we cut the dot and remove the v, that just the number is left. On some products you have to cut it in another way, like on PHP, where you have the major and the first minor version, then the cut command looks a bit different. But this is the approach to find out the version number, just a simple call of that. And back to our Icinga instance, here is a system which has 3 end-of-life checks, which is a LAMP system. I check the operating system, the PHP version, and the MariaDB version. The next check I want to show, it is from the category with a health check with curl. I wrote an app monitor which is able to fetch information from different applications and render it on a UI. And that UI I do not want to open next to Icinga, and that's why this tool has an health API. And this I can request. It is done with an HTTP request. I verify the status code if it is 200, and then apply a JSON filter with JQ command. So. For that, I start a Docker container because I cannot connect it online. I set a variable named URL to verify the URL /API/health. And if I request it, I get a result with a key health, and below that, that key is a second key named status, and in that I expect the value OK. And my check script gets these parameters to fetch the URL. Then the JQ filter is that one. They are separated with a dot. And then I check in the body or in the content, I search for the value OK, which now works because we have seen that there the value OK is in the response. And back in the Icinga Web UI, we see directly that output, what we just have seen on the terminal. I'm nearly finished. The last section is Icinga Web and what kind of modules we use. For me, the director is a definitively must because it generates config files I do not want to touch myself. it configures hosts, services, notifications for us with pulling or with pushing requests. With its API, we can do a lot of things. The second tool is Nagvis. It helps to visualize the application, how does it work, or how a part of an infrastructure works. It is helpful not for me, but more for people who are seldom in Icinga and see just a flat list of many hosts, of many checks. And for our product owners and developers, it is helpful to get an overview what the application's currently doing. I also mentioned that we installed Graphite in the first phase of our Icinga installation, and it is helpful to estimate if a problem occurs. For instance, if the disk space is full, when does the action started, which is writing the disk? Was it yesterday in the evening, or is it a process which is for a few weeks or months? A little eye catcher on the Icinga Web installation below the images directory, we put subdirectories for icons. For the operating system, the services, we put the original icons of the product, and there's an icon set for other checks. Then we use the service filters. If you navigate through Icinga, they will automatically apply it to show different pages. And if we use the service filter on the end-of-life checks, for instance, then we have an information how many systems are affected which are going end of life. It is a very helpful information to know if there are 5 or 50 systems and products you have to update in the next few time. It makes a very big difference. And this is a very helpful tool to see when PHP applications have to be updated, or operating systems or databases. We use such filters also for our maintenance windows to see how many systems need updates and which not. All these filters, which we type there in the fields, they are written as URLs, so you can bookmark it, or you can link it in your ticket system, or you can give it a developer or someone else that he sees directly the same view like you created. This is very helpful. We gave other users access, product owners and developers. They see their own machines only. It is done by host groups where we put the machines of an application or of a department. And we have email notification like many others here too. I would like to say thanks to Icinga team to have such a great software and offer it for us as free software. If something comes to my mind, I just can create a check and I will see it. A few weeks ago, I talked with a colleague. He is also a system administrator at another institute of our university. They have a commercial monitoring tool, and he wants to see this and this and this, but they are limited by licensing, have a limited count of checks, and he has to think, he has to decide what check I have to install, and I just can implement whatever I want if something comes to my mind and want to see more. Thank you.
So we are totally over time, but we take this question. Click.
Yeah, I have a question about Nagvis. We also use Nagvis for visualization, and it's deprecated, isn't it? I think it was 2017 it was deprecated.
I have seen that they currently updating the software. The last release was beginning of the year, so they are still developing it. But there's some issues I don't like. I will try Meerkat, which was presented yesterday. But in my opinion, it is not finished.
You use old or the new backend? The old one for Icinga, probably, without Redis.
Oh, I don't know. I just installed
Okay.
Nagvis module I found on GitHub.
Oh,
I think the current one.
yeah. Okay, thank you.
Is there another question? So we take this last question and then we move on.
Are your check plugins available as open source code or?
Yes, our check scripts with Bash, they are open source. Yes. I must. Oh, can I go back? It is a GitLab instance at our institute. Shift F5. Oh, no, that was wrong. Maybe I can show you. We are still here for a while. You're welcome.
Okay. With that, Axel, I would say again, thank you very much for your amazing talk.